Hi dear children, I am teacher Geeta. This is grade 9 physics revision topic work, energy, power. Before I gave some videos separate each small topic, now I together the whole unit giving a revision explanation. Here it is work, energy and power. Physics, the concept of work. Work is done only when a constant force applied on an object causes the object to move in the same direction as the force applied. And work is the motion against opposing force. And here it is a constant force, what is considered as work done in physics. When you push a heavy shopping trolley for 10 meter, you lift your school bag upward by 1 meter. All these examples of work done. In these cases, we have to say that work is done. When we will say work is not done or what is not considered as work done, you push against a wall. There is no movement. You can see that one. Then jumping continuously on a same spot. You are not moving in any places. That same position you are. And holding a chair and walking around the classroom. So in these cases we can say that work not done. The work can be calculated by force multiply the distance moved in that direction. Then short way W is equal to F multiply S. The unit of work is joule. Now energy. What is the definition of energy? Energy is the capacity to do work. There are different types of energy. Kinetic energy, potential energy, electrical energy, chemical energy, solar energy, nuclear energy. You know that what is kinetic energy? The energy possessed by motion. Potential energy possessed by position. And electric, the energy possessed by the current. And chemical energy, that stored energy in food or battery. And solar energy, the sun producing energy produced by the sun. Nuclear energy, the nuclear reaction producing energy, that is nuclear reaction. All these are the examples of energy. Energy is the capacity to do work and the unit of energy is joule. And now we are explaining the kinetic energy. The kinetic energy is a form of energy that a body in motion possesses. A body at rest will possess kinetic energy? No. When it possesses motion, we can say that it has kinetic energy. Examples: bullet shot out from a pistol, the helicopter flying at 120 km per hour. All this moving, so we have to say this has kinetic energy. The amount of kinetic energy of a moving body depends on mass of the body and velocity of that body. When either mass or velocity of moving body increases, kinetic energy also increases. And here it is, see, the mass doubles, kinetic energy doubles, velocity doubles, kinetic energy it's by 4 times. It is increasing by 4 times. But this is showing the equation of finding kinetic energy. Kinetic energy equal to half mass into velocity square, half mv squared. Here also the unit is joule, same as the work done. But from the formula, what can you infer from the change in kinetic energy? So the mass doubles, kinetic energy doubles, the velocity doubles, the kinetic energy increases by 4 times. Okay, this is about kinetic energy. Next one is potential energy. Potential energy is the energy possessed by an object as a result of its position or condition. The two kinds of potential energy are gravitational potential energy and the elastic potential energy. Now in this unit we are studying about gravitational potential energy. And gravitational potential energy is the energy that can be possessed by an object due to its position. And in physics, ground level is normally assumed by zero gravitational potential energy. If they are in ground, any object is on the ground, we have to say it has zero gravitational potential energy. But any object that at ground level has 0 GPE, and if the object is lifted a certain height above the ground, its GPE has increased. So we have to say the raised object have gravitational potential energy. And when a chair lifted from the ground a distance of 1 meter and you are sitting on the 3rd story of the building, then we have to say that you have gravitational potential energy. And how to calculate gravitational potential energy? That is mass multiply gravitational acceleration height above the ground level, that is mgh, gravitational constant. But here it is some questions there. You lifted your bag to the top of your table. What can you say about GPE on your bag increases? If you lift the same bag on the moon, what happened to GPE? Same, it is increases. And will GPE the same on the earth and moon? It is less. But remember, the unit is also joule, but this is about gravitational potential energy. And the next one is principle of conservation of energy. What is conservation of energy? The energy cannot be created or destroyed. It can be changed from one form to another. The energy of an object can be thought of as the sands in the hourglass. Same like the sea. Energy always remains same or fixed in a quantity. But the sand can change position from the top to bottom and bottom to top. Likewise, energy can change in one form to another, if kinetic to potential or potential to kinetic, and different way it has changed. It can change from one form to another. That energy cannot be created nor destroyed. It can change from one form to another. For conversion of energy, here it is the term used to denote change in energy from one form to another. There is a burning candle. What is the energy change going on? Chemical energy change into heat and light energy. And fuel, burning of fuel, chemical energy change into heat and kinetic energy and electricity also produced. Nuclear explosion, nuclear energy change into heat and light. In a spring, elastic potential energy change into kinetic energy. This is a conversion of energy. The principle of conservation of energy states that energy cannot be created or destroyed. It can be changed from one form to another. Now, what is power? Power is defined as the rate at which work is done. This is the equation. Power is equal to work done divided by time. If W is the work done in time T, the average power is P is equal to W divided by T, work done divided by time. If dW is the work done in a small time interval dt, then instantaneous power is equal to P equal to dW divided by dt. And power is a scalar quantity. It has only magnitude, no direction. So power is equal to work done divided by time. Work done divided by time. And here it is a simple problem. What power is developed by a 55 kilogram person who does 20 chin-ups. Height is 3 meter in 45 seconds. But here it is power is equal to work done divided by time. Work done is equal to force into distance, that is 20 chin-ups, that is 20 multiply 50 kilogram multiply height is this is mgh, gravitational constant 9.8, and height is 3 meter. Here it is energies, work done is gravitational potential energy is work done divided by them. So it is racing, the object is racing, so we have to use this equation and divide by time 45 seconds. So we will get 718.6 watts. But this is about the power. Work done is equal to energy conserved, that we have, that's why we have to use this equation. I think all of you understand power is defined as the rate at which work done. Next one is efficiency. Mechanical system efficiency. Efficiency is the ratio between the useful power delivered by a motor and the power that you supply to the engine. Efficiency has no unit and it is usually expressed in percentage. So this is the equation used to find efficiency: useful output work energy divided by total input energy into 100%. But this way we have to find the efficiency. But this is about all this unit work, then different types of work, how to calculate work, and then energy definition and different types of energy. Mainly we have to study about kinetic energy and gravitational potential energy, the equation for that one. Then we study about the power and the equation also, and next last one is efficiency. Here also one equation. Remember all this equation, and higher classes also we need this one. Okay.